So this section is quite long. It deals with variables, data types, comparison operators, and assignment statements. So a lot of what we do in a program is in this section. Basically, if you want to store data in your program, you have to create a variable, and declaring the variable actually reserves a little spot in memory. So you have somewhere to store the data. And when you declare the variable, you have to use a data type, okay, because that tells the C# compiler how much space you need. And then you have to give the variable a name. Okay, and so we have several different data types that you can use. And so then you would declare the data type followed by the variable name. And the variable name can pretty much be anything you want. However, the standard for a multi-word variable is to use camel case. So if you had something like start date, you cannot put a space in a variable name. So instead of a space, you just capitalize the first letter of the second word. That is a standard in C# coding. So the rules that you need to think about when you are naming your variables is that you can start them with letters, digits, or underscores. Underscores actually have specific meaning when we get into creating classes. They are for private variables. So I would not use underscores unless you are in a class and you are creating a private class member, which is a variable in that class. Variable names must begin with a letter. They cannot contain white space. And instead of the white space, we do the camel case. It is case sensitive, so upper and lower case are different. You shouldn't use reserved words. So these are words that are part of the language. So while, we have while loops, right? So while is part of the language. Switch, case, for, any kind of command that you would use in the language is a reserved word, and you cannot use it for a variable name. There are no limits on the length. If you really enjoy typing, by all means, go to town on your variable names. I try to keep mine rather short because I don't like to type that much. So creating or declaring the variable reserves the space in memory, but it does not assign a value. To actually assign a value, you need an assignment statement. Okay, and so once you assign a value, then that value goes into memory. So a little bit more on data types here, specifically size of the different data types. And so integer is the default for whole numbers. And this is the range as far as size that you can use. So for most numbers, that's probably going to be good. If for some reason you're going to be creating a super huge number, you can use long. But if you want to use long, you have to put an L at the end of the value. And that tells C# that it's a long whole number. Then we have some real numbers, float and double. The default is double. And that is more precise or more accurate than float. If you wanted to store float, it's very similar to integer and long. If you're going to do float, you have to put an F at the end because the default is double. And for what we're going to be doing, using integer and using double are fine. String, this is for any text, basically that's more than one letter or more than one character. You're going to put it in double quotes. Okay? Anything in double quotes is a string. A character, so that is just one value. That is going to be surrounded by single quotes. Boolean is either true or false. Okay, so I do have some coding examples you can look at. For Boolean, you are either going to set it to true or false, and you'll notice there are no quotes there. It's just true and false. And how Booleans are typically used, if you have a Boolean variable, you can use it directly in an if statement. So how that would read is, if workday is true, execute this. If holiday is true, execute this. Okay, and Booleans are used a lot in selection and repetition structures. So we have Boolean variables and we also have Boolean expressions where you've got a variable and some kind of an operator and a value that you are checking. And the expression will test to true or false. And this is where comparison operators come into play. And I think you guys are all familiar with these, but for equality, we use two equal signs. And then we've got not equal, greater than, less than, greater than or equal, less than or equal. Okay, and so quite often we end up with a Boolean expression that we are testing in our selection structure or even in our repetition structure. So this little program, some of you might recognize it from last semester. We've got the minimum age of 12 for a roller coaster. And then we've got two people, Franny and Taylor. One is 10, one is 20. If the Franny's age is greater than the minimum, she can ride the coaster. So the minimum was 12. So it's saying, is 10 greater than 12? No. So then it's going to come down to the else and say, oh, Franny cannot ride the coaster. Is Taylor's age greater than 12? So is 20 greater than 12? Well, yes, it is. So yes, Taylor can ride the coaster. Okay, so that's all that code is doing. Here we've got a nested if else, and we are checking the student score. So we have a student score set to 83, and we're saying if that score is greater than or equal to 90. Well, 83 is not. So then we come down here. Is 83 greater than or equal to 80? Yes, it is. So we execute this line. Okay, and we're done. If it was not, then we would go down to the next line. Okay, and that is how a nested if else works. So we have our Boolean variables that get checked. We have Boolean expressions that get checked. And we also have logical operators. And logical operators let us check for more than one expression. And we have and, or, not, and a little something called XOR. So, or, I think a lot of you are probably familiar with this. If you use a logical or, okay, you will have one thing you're checking with an or, the next thing you're checking with the or, and you can continue on. You'll notice that you have to have the variable name in each one of these checks, along with the operator and what you're checking. With an or, only one of these needs to be true. So once something tests true, the whole thing is true. Okay. And so looking here, we've got department equals to equal 3. So if department is a 1, no, it's not. If department is a 2, no, it's not. If department is a 3, yes, it is. So that means everything is true, and it's going to print that out. Okay, and then the department is still 3. So then we're going to come down here. Is the department 10? Nope. Is the department 20? Nope. Is the department 30? Nope. So they're all false. So then it's going to come down here and print that out. Okay, so that is how the OR works. Logical and, this basically requires that everything is true. So every condition that you're checking needs to test true for it to be true. So it is more restrictive than the OR. And let's take a little look here. Here we've got department number set to 1 and region is mountain. We're saying if the department is 1 and the region is mountain. Well, that is true and that is true. Okay, so that means the whole thing is true and this gets executed. Now let's look at the next one. The department is 1, that's true, but the region is west, that is false. So if one of them is false, it's all false. And then it comes down here and executes that. So the problem with the logical operators is people who are new to coding get confused on when they should use or and when they should use and. And they will sometimes create impossible conditions. And this is an example of an impossible condition. The department number cannot be a 1, a 2, and a 3. That is impossible. That will never test true because the department number can only be one value. Okay, so make sure that you're looking, you're kind of thinking through the operator that you're using. If only one of them should be testing true, then it has to be or. If all of them need to be true, then it needs to be and. The logical not basically changes the value to the opposite. So it can be a little confusing, not logic. I will use not equal to quite often, but I don't often use not object like this. Because basically what this does is it evaluates this expression. Okay, and let's say here we've got a department number equal to 3, right? So just looking at this part, is it a 1? No. Is it a 2? No. Is it a 3? Yes. So that would make this whole expression true. But we have a not here. Okay, so that actually says that it should be the opposite, which is false. So that is, to me, super confusing to use it like this, but you will see it being done. So here we've got another example where we're using this not business. And so we've got the department is 10 and our region is mountain. So it's looking for a department of 1, 2, or 3. Well, we are a department of 10, right? So this would be false. Okay, so now this is actually not looking for true anymore. So if it's not one of these 3, okay, then they get the bonus. And here we've got region of mountain. So we've got region west and region mountain. That would make this true. So if it's not one of those, then it's true. Okay, otherwise it's false. So this is going to test false because we got mountain in there. Okay, so that is not logic. XOR. XOR is not used very often. If you have multiple conditions, only one of them can test true. So if we were to use XOR up here, only one of these could be true. If more than one was true, it would test false. Okay, so in this example, if this is true and if this is true, it is going to be false. Okay, if this was true only and this was false, then it would be true. Okay, so with XOR, only one thing can be true. Okay, that's what you have to remember with that. And with these Boolean expressions and our ability to use and, not, XOR, um, or you can actually create pretty complicated expressions. And you just need to really think through what you want it to do. So what this is saying is they should not be salaried. They should not be hourly. They need to have something in piece rate and they need to have something in pieces. Okay. And if all of that is greater than 100. So basically it's trying to calculate the piece rate value. Okay. So that is a more complicated expression. Would I actually code it that way? No. I would try to make it much more simpler. But that just kind of gives you an idea of, how you can really muddy things up with these complex Boolean expressions. Okay, so here's another one. If they're not salaried and they're not piece rate, well, that would mean they're hourly. So if the hourly is true and their hours is less than 40, then we'll calculate this. Otherwise, we're going to calculate overtime. Now, did they really need to test salaried and piece rate? Probably not. Probably could have just tested hourly and hours. Okay. So you can always make things simpler. Character values. So a character is just one letter, number, or symbol, and it is in single quotes. C# has a lot of character testing methods that you can use. And I've got some of them listed here. And this is just checking the value to see if it is a number, to see if it's a letter, to see if it's a symbol. Okay, and so this is an actual program you can run, and you can actually sub in different values here to see how it's going to work. But you can see that it is calling an isLetter method, which is part of the character class, and it's passing, in this case, first. So that should come back as true. It is a letter. And then it's going to see if it's uppercase, which should also be true. So it will come back that it's uppercase. Then we're basically doing that same test for the second one. Is it a letter? Well, no, it is not. So it's going to go down here for the third one. That's not a letter. And neither is the fourth one. So the only output we're going to get is for the first one. Okay, and then we take those same characters and now we're basically testing for numbers and digits. Okay, and you can see that this is the only one that should test positive for those two things. Okay, and then we do the same thing. We're testing for a symbol or a control character. And these are all programs you guys can run. Yeah, you can just copy and paste them right into Visual Studio. We looked at a lot of data types, and C# does include a generic data type called var. For those of you familiar with JavaScript, JavaScript also has a generic data type called var. In C#, if you're going to use var, you have to assign a value, because that is how C# knows what kind of data it is storing so it can reserve this spot in memory. So, if we did something like this, it knows it's a string. If we do something like this, it's going to infer that it is an integer. Okay, so you can use var as long as you're assigning a value. Constant variables in C# are the same as any other language. They don't change. That's why they're called constant. And to make a variable constant, you still need the data type, the variable name, and you have to assign a value. All you do is put the keyword const at the beginning. Okay. And as far as what you can make constant, any of the normal data types are fine. You cannot make the var data type or a static variable constant. Okay, but as long as it's int, float, double, string, bool, all of those normal data types, they can be made constant. So here's a little example where I've made the rate of pay constant. And this is another one you guys can copy and paste. Assignment statements. So you can actually create the variable and wait to assign a value like this, or you can assign the value when you create it. So this is called initializing. If you create the variable and assign a value at the same time, you are initializing. Okay. Otherwise, you can create the variable and then put the data into it later. Okay. And which one you choose to use really depends on how you're getting the data. You may declare variables above a loop, and then inside the loop, you are prompting for console input and retrieving the data that way. In pretty much all languages, there is a shortcut method of doing arithmetic. So it's not just C#. All languages have an increment or a decrement character. So 2 plus signs, either in front of a variable or after a variable, will add 1 to the value. 2 minus signs, either before or after, will subtract 1 from the value. So it's basically the same thing as, coding out a longer version. So x plus plus, assuming the variable is x, adds 1. And this is the same thing as x equals x plus 1. Okay? The end result is the same. Most developers would just do x plus plus because that is faster. Now, what does this post or prefix business mean? It makes a difference as far as when the value is added and used, or in the case of decrementing, when the value is subtracted and used. Okay, so let's take a look at this. And I think this is probably the best way for you guys to understand what this is doing. So I'm just going to quick create a new little project. I'm just going to call it testing. Pop this over here. Okay, so we have A and B. They're both set to 20. You can see I'm doing a pre-increment here and I'm doing a post here. So let's see what those values are. Okay, so you can see here I'm pre-incrementing and it used the value. Here I'm post-incrementing and it did not. And so decrement is going to work the same way, right? So if I change this to pre and post, okay, that first value is going to go down and the second value won't. I mean, it does go down, but you're not going to see it yet. So in addition to having the increment and decrement, we also have shortcuts for multiplication, division, all of that fun stuff. So instead of keying out total equals total minus 10, we use a shortcut and we say total minus equal 10. Okay, and that just saves us some typing. And you can do that with all of the arithmetic operators. Okay, so if this was multiplication, it would just be total asterisk equal 10. Addition, it would be total plus equal 10. Okay, this kind of becomes second nature, just because it does save you a lot of time. And once you start using it, I do think you guys will like it. And let's see. Here we are adding to price using plus equal. Okay, so this is the same thing as price equals price plus, whatever it's reading in from the queue. So hopefully that makes sense. If it doesn't, if you want to practice a little bit, you can copy this. I'll paste it right in here. And you can actually change it into the long form and the result's going to be the same. Okay, so now if I went back to the short version and ran it again, I'd have the exact same result.